So now we learned to solve systems, nonlinear systems, by substitution and elimination. So it's kind of a review of, you're going to be doing this on the quiz, but it'll be with linear. But this will be the nonlinear. These are the SOL, essential learnings, or whatever they call them. And notice the first one says, predict the number of solutions to a nonlinear system of two equations. So I've never seen that asked on the SOLs, but I mean, the kind of question they could ask is, what's the most number of solutions that you could get if the system consists of one line and one quadratic? That would be 2, right? I mean, in your mind, it says quadratic. Quadratic is more general than just saying parabola. But in the end, if you think parabola, you're going to come up with the right answers, right? So one parabola and one straight line could be 2. What else could it be? How many other possibilities of solutions could you get? Could be 1, right? Could be tangent, right? Or it could be like the axis of symmetry, or it could be 0. What if it's 2 quadratics? What are the most number of solutions you could get? Actually, you could get 4. Try to imagine if you had one parabola that was opening up and another one was opening to the side and they were right over each other. You'd have 1, 2, 3, 4 solutions. So, I mean, I've never seen that asked, but that is kind of predict the number of solutions to a nonlinear system. That's kind of what it implies they might ask. We'll see as they keep changing the test year to year. So we have, these are the same directions that I put up when we were doing this for linear systems, but I just added in blue what might change because now they're nonlinear systems. Like now we might have x squareds and y squareds. So when we solve one equation, we don't necessarily solve for x to the first or y to the first. If actually every place you see it, it's x squared, then it's enough to solve for x squared and then substitute for x squared. But, I say that, I think none of the examples we're showing actually do that. Maybe some in the homework do. So it's possible you would solve for x squared or y squared. And then you would substitute for that one in the other equation. You might have more than one answer, so I'll say there's a possibility that's going to be plural. And then your solution is going to be a set of points now, not just one, and not infinitely many, which you can't really write with as a set of points. Again, those are the kind of modified directions. So here's an example. I think we did this one by graphing before, but still. The first one is a circle. The second one is a straight line. So how many solutions might we get? You might get 2, right? Could be 0 or 1 or 2. So the first step of substitution would be solve one equation for one variable, but actually we already have one solved for one variable. So we can go right ahead to the second step, which is substitute for that variable in the other equation. Right? So I'm going to substitute the x squared plus negative 3x plus 10 squared equals 10. So now we just reduced it to one equation and one variable, which we should be able to solve. Looks like it's going to be a quadratic, so we're going to have to think of the ways we solve quadratics. So x squared, FOIL that, I'm going to get plus 9x squared minus 30x plus 100 equals 10. Combine like terms. That'll be 10x squared minus 60x and plus 90. Okay, so there's a quadratic, standard form, equals 0, right? The first thing to think of is it factorable? Yeah, well, it has a factor, there's a common factor of 10, so what can I do with that? Yeah, just divide it out. I mean, you could say factor it out, but factoring implies you're going to leave it as 10 times parentheses something, and you don't have to do it that because it's an equation. I can divide both sides by 10, and then I have x squared minus 6x plus 9 equals 0. Is that factorable? Yeah. It's minus 3 minus 3, so this is x minus 3 squared equals 0. Okay, so what does that mean the value of x is? X equals 3. Okay, so we only got one x value. Okay, how are we going to find the y value? Plug it in, go up here, y equals negative 3 times 3 plus 10. So y equals 1. So it looks like we only have one solution this time, and it is the point 3, 1. Right. Which we did that one in class the other day. Okay, so try to do the same thing with that one. Right, so it was already solved for y. So I substitute for y in the other equation. Now that's a FOIL, right? And when you get done with it, it should be x squared plus 2x plus 1 when you finish FOILing that. And then the 2x's cancel, and 1 minus 10 is negative 9. So x squared minus 9, you need to solve one way or the other. I mean, you could like add 9 and then take the square root of both sides, or you can factor it. Just either way, you got to get two answers, 3 and negative 3. And then you got to go in one at a time, plug into this equation, right, with 3, that's what I did at top, and then with negative 3. So 2 points, that's the most we could expect, and that's what we got. Okay, elimination. Again, I just kind of modified what I'd said before for linear systems. You know, I mean, when you get into quadratics, there is a standard form for quadratics, but we're not, you don't really have to have it in standard form. The main thing is you just have to have variable terms that look like they'll cancel if you add or subtract. You know, wherever they are in the equation, it doesn't matter as long as they're on the same side of the equal sign. That would be, so things won't look so pretty as they do when they're linear. And let's see. And now you're going to have to make, you know, if you've got squared terms involved, you know, you might be making squared terms cancel. And again, you might get more than one answer. Good. Okay. All right, so here we go. Now these are both in standard form for a quadratic. And the standard form for a quadratic is, first you have the squared terms, then you have the linear terms, then you have a constant term, and it's all set equal to 0. Then it's called the general form. So usually it'd be like in order. First the x squared term, then the y squared term, then the x to the first term, then the y to the first term, and then the constant. Now looking at these here, I could tell you that right away. The first one is an ellipse, and the second one is a hyperbola. You can tell it by looking at the squared term. Now we know if it's x squared plus y squared, that's a circle, right? In fact, if it's 2x squared plus 2y squared, that's a circle. If the coefficients of x squared and y squared are the same, then it's a circle. If the coefficients are not the same, but they're not equal either, that's an ellipse. It'll be a elongated circle. And if the coefficients are opposite, that's a hyperbola every time. So let's see, if we're going to do elimination, are these equations set up so that if we add them together, one of the variables cancels? You know? Yeah, I mean, usually if there's a linear term in there, that's probably not the one that cancels. So this having the 90x there, probably not going to be the one that x doesn't cancel. But if you look y, there's no y to the first, and the y squareds are already opposites of each other. So what will happen if we add them together? Cancel. We eliminate. So that'll be the strategy, right? Right away we will add them up. So this is going to be 10x squared. Cancel. I got a minus 90x and 216 minus 1 plus 215 equals 0. Okay, so is it factorable? I mean, at the very least, you could take out a 5, right? So let's see what it looks like if I take out a 5. 2x squared minus 18x, and 215 divided by 5, 49? No, 43, plus 43. Okay, is that factorable? Meaning, are there factors of 86 that add up to negative 18? And you know, off the top of my head, I don't know. So what else could I do? No. Solving quadratic equations when factoring isn't going to work. Quadratic formula, right? Use the quadratic formula. So let's see what happens if I do that. I'm going to get x equals negative 18, which is 18, plus or minus the square root of negative 18 squared minus 4 times 2 times 43. All over 2 times 2. Okay, so x equals 18 plus or minus. Okay. So what is negative 18 squared minus 4 times 2 times 43? Negative what? Negative 668? Okay. Over 4, sorry. Okay, well, what kind of solution is that going to be? If it's a square root of a negative number, that's imaginary, right? And so if it's imaginary, that means we're looking for the intersection of points in the real number system. So these don't intersect. That's what it looks like when they don't intersect. So this is imaginary, so no solution. Okay. Is that a right calculation, 668? Yeah, I got something like that too. So, watch. So I'll tell you what you did if you got that wrong. You did like this. You said negative 18 squared, no parentheses, minus 4 times 2 times 43, right? And you got negative 68. What did you do wrong? No parentheses around the negative 18, right? You got to know better than that. So it should have been, second enter. If I just change that minus to a plus, because it would have been a plus. Plus. Enter. Oh, guess what? Because it doesn't like that syntax, I guess. Second enter. Second enter. I should have just deleted it. Delete. Now I go enter. Negative 20. That's more like it. I know last class it was not negative 668, but it's not all. Sometimes I make the mistake in first class and I don't make it in next. Okay. So try that one. See if you could use elimination to eliminate a variable and solve. now my pen stopped. So which variable was set up to cancel? Again, it's like the y, right? So we can add them up. 2x squared. Y's cancel. Oh, sorry. 2x squared minus 16x. And 39 minus 9 is 30. Divide out a 2. X squared minus 8x plus 15. Factor. X minus 5 times x minus 3. So x equals 5 and 3. Okay, now where do you go to find the y values? Yeah, I mean, you're going to have to use probably the second equation is the easiest one. But I'm going to do something a little different than I did the first block, because honestly, just to make it easier to solve, I'm going to actually solve it first for the y squared. So let's make this y squared equals x squared minus 9. Okay, now when I plug in 5, I'm going to get y squared equals 5 squared minus 9. So that is 25 minus 9, which is 16. So y equals plus or minus 4. Right? Don't forget the plus or minus. That's 2 points. Right? That's the point 5, 4 and the point 5, negative 4. Okay, now let's plug in 3. Y squared equals 3 squared minus 9, which is 0. So y equals 0. And that is the point 3, 0. So we had 3 intersection points between a circle and an ellipse. Okay, last. Right, so here's one that you have actually linear terms in x and y in the same problem. So which variable are we going to be able to set up to cancel? The y's? Oh, how would you get the y's to cancel? Well, I mean, if you multiplied, if you're looking at the x's, right? If you multiplied this one by 4, right? And then you got your negative 4x, but you don't have anything to cancel the x squared, so it's not going to work. What happens if you multiply this one by 4 because you see that 4 right there? Well, actually, 4 times 2y is 8y, so it makes both of them line up to be canceled at the same time. So, I mean, it doesn't always happen that way. This problem's obviously been very carefully constructed so that it will work. So that's going to be the strategy. We'll multiply the bottom one by 4. And that is going to give me x squared. And 4y squared minus 4x plus 8y equals 20. Okay, that's the equivalent system. And now what am I going to do to cancel the y's? It's a subtract. Right? You could have multiplied by negative 4. Is that what you did, Matt? Okay. So now we're going to subtract. The x squared stays the same. The 4y squared minus 4y squared is canceled. 4x minus negative 4x plus 8x. And the 8y minus 8y cancel. And then we've got equals 8 minus 20, negative 12. So let's get everything on one side. X squared plus 8x plus 12 equals 0. Okay, factorable. 6 and 2. So x plus 6, x plus 2. So x equals negative 6 and negative 2. Okay, then what? You're gonna have to find the y values now, right? Because we got the two x values, and that to me looks like it'll be a little more complicated. But I'm probably going to use that second equation, and just to give myself more room, because this takes a little bit of room, I'm gonna do this on the next slide. Y squared minus x plus 2y. Y squared minus, what did I say? X plus 2y equals 5. You sure that's what it says? Yep, that's what it says. And we're saying we're going to do this with negative 6 and negative 2. So with the negative 6, right, I'm going to get y squared minus negative 6 plus 2y equals 5. Y squared plus 6 plus 2y equals 5. Right? Subtract the 5, rearrange the terms. Y squared plus 2y plus 1 equals 0. So that's factorable. Y plus 1 squared. So what is the value of y? Right, y equals negative 1. So the point that comes from that is negative 6, negative 1. Okay, then we got to do the negative 2. Right. Y squared minus negative 2 plus 2y equals 5. Y squared plus 2 plus 2y equals 5. Y squared plus 2y minus 3 equals 0. And lo and behold, that is factorable too. Y plus 3 times y minus 1 equals 0. So the y equals negative 3 or positive 1. So that's 2 points. Negative 2, negative 3, and negative 2, positive 1. So those are all the solutions, right? 1, 2, 3. 3 points. What kind of shapes were those? The first one is an ellipse. The second one is a parabola because it's just one x squared term. Okay. That's it.